Good morning, students. So today we're going to solve question 8 from GATE CSE 2025 set 1. The question states that a fair 6-faced dice. Okay, so a dice normally has 6 faces only. If the normal dice that you must have used in Ludo and that snakes and ladders, all of them have 6 faces, right? And those faces have these numbers 1, 2, 3, 4, 5, 6, right? So this part tells about the basic assumption, right, about the dices. Then it tells is rolled thrice. So the same dice is thrown 3 times. Okay, what is the probability of rolling 6 exactly once, right? What is the probability of rolling 6 exactly once? So basically, if the dice is thrown 3 times and the results of them are noted down under over here, then only one of them, right, exactly once is being mentioned. 6 is present exactly once, so 6 may come over here, may come over here, or may come over here. The other thrown dice's outcomes must be something different, right? The outcome normally can be from 1 to 6, that is correct, but the outcome for the places where 6 is not present would be from 1 to 5, right? From 1 to 5, right? This aspect that the 6 could come in the first or the second or the third, I have represented it inside of this box, and from that assumption you can see that the number of permutations for this arrangement would be exactly same as for this arrangement, because these blocks are equivalent and there are 2 of them in all of them. So if we were to calculate the number of permutations that exist for this, we can directly multiply that by 3, and that is going to give you the number of permutations for exactly 1 6, right? So let's calculate for this. Let's take this particular case and then evaluate it from it further, right? This 6 is fixed over here, then these 2 blanks can have from 1 to 5, right? From 1 to 5 elements they can have, right? This can have 5 elements, this can have 5 elements, and for every 5 element over here there are 5 elements present here. That multiplication can be used over here. That is going to give you 25 outcomes for this particular arrangement, right? So 25 for this, 25 for this, 25 for this. What do we get? 3 times 25, that is going to give you 75 arrangements, right? And if there were to be no restrictions, right, exactly once is the case for the particular probability that you are trying to find, right? But the total number of permutations has to come in the denominator for probability to exist, right? That is the concept of probability, right? Probability goes from 0 to 1. How does it go from 0 to 1? Because the number of permutations that are in our favor is divided by the total number of permutations that may exist, right? So that is what we have to find. So for every blank, if there were to be no restrictions, there are 6 possibilities, right? 6 comes over here, 6 comes over here, 6 comes over here, right? So 6 times 6 times 6, and that is going to give you 216, right? So the favorable permutations are 75 and the total number of permutations are 216. So the answer would be 75 by 216, and that is going to give us the first option. The first option is the correct option, right? Obviously this is purely analytical and you may not be able to grasp it if this is the first time you are facing this kind of thing. So that you have a better understanding of how exactly this analytics actually work in the case for all permutations were to be considered, I have shown that also. So this arrangement over here, I have printed the case for all permutations that the triple throw of the dice will produce, right? 111 it will produce, 112 it will produce, 113 it will produce, 114 it will produce, and so on like this, right? And then so on like this, and then so on like this, and then so on like this, and like this, right? All permutations I have written over here. I will place a link for the this PDF in the chat. You can actually download this PDF and then go through it if by yourself also to have a better understanding. And then I have marked by highlighting the particular arrangements that are going to be having exactly 1 6, right? So how many arrangements are there in this particular this block, right? So 1 6 over here, 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 and the numbering for this is 1 to 5. So this is going to be 5 from here and exactly same 5 from here, right? 5 plus 5 is 10. The same arrangement is going to come over here, 10. You see the first dice throw is dictating the block element, right? So for 1 it is producing 10, for 2 it is producing 10, For 3 it is producing 10, for 4 it is producing 10, and 5 also it is producing 10. But for 6, when the first dice throw is 6, then all of these elements are also included, and the previously included element like this now have 2 6s, so they do not possess the property of having exactly 1 6, right? So that is not in their favor, so now they are removed. So total number of permutations that are being produced by this particular block is, well, 1 2 3 4 5 in the horizontal, and 1 2 3 4 5 in the vertical. So that is going to produce you a total of 5 cross 5, that is going to give you 25 arrangements, right? 25 arrangements. Let's add them together, right? How many 10s are there? 1 2 3 4 5 10s are there, plus a 25. 5 times 10 is going to give 50. 50 plus 25 is going to give you 75. This is the 75 that we got from analytical approach before, and from direct expansion also we are getting 75 in favor of our particular probability that we were trying to find, right? In favor of our probability that there are 75 particular arrangements of the dice that I have clearly shown over here that are going to add towards our probability, and that is 75, and 216 I have already calculated as the total number of possibilities, right? You can also see that every block has 6 6, right? So 36 number of permutations that every block is providing, and there are 6 blocks, so that is going to give you what? 216. Exact same thing represented in a different manner. I hope that this will help you. Obviously, you may think that I cannot write all these arrangement examination. I don't expect you to write all these arrangements in the examination. I'm just presenting it to you so that in future, when you use this analytical approach, you may have more confidence in your deductions, right? That is, this whole approach is basically for that. Even I, for that matter, did not write all of these by my own hand. I made the computer produce it. So this is a small Python code that I use to produce these blocks. I have added it over here. Obviously, this is out of syllabus, not really included in that part, but I have given it to you so that in future you can also use something similar to this. It's very straightforward. Python is like English, right? You can directly read it. So if I were to be from 1 to 7, and last part of the range is not included, so 1 to 6, and then 1 to 6 and 1 to 6, right? And I, J, K are then printed with spacing being provided by these particular commands, right? And that is the whole thing. I will provide the link for this PDF. Go through it if you have not yet understood, and I do think that you must have understood it. It's extremely simple question, and with that I'm going to wish you a very good day. And if you like the video, like and subscribe, and thanks for watching. Good day.